So today we're going to take a look at section 1.2. Okay, 1.2 focuses on using the graphing calculator to solve different kinds of problems. Looking at what this term is here, it's called a complete graph. Okay, I'll explain what that is. This section's pretty short, so we'll do 1.2. We'll start 1.3, but I don't think we'll finish it today. Okay, so we'll do about half of it.
Would 1.3 be on the test? Or?
1.3 will be on the test, yep. Whatever we get to.
Yeah.
We'll see how far we get. All right, so first thing they give you in section 1.2 is just kind of an outline of how to go about solving a word problem. All right, so it's just kind of a general strategy. All right, so first thing you always want to do when you're trying to solve any kind of problem, read it through and try to write down what you're given and what you need to find. Right? You've got to be able to figure out what are they telling me that I can use, and then what are they really asking me to find. Right? If you can't figure out what they're asking you in the question, you're definitely not going to be able to solve it. A lot of times when they ask you what you need to find, this usually involves picking a variable, or maybe two, depends on the problem. Okay? Picking a variable to represent what you don't know. Okay, second step is to figure out what's probably the best method to solve this kind of problem. Okay, is this the kind of problem where drawing a picture might be the way to go? When we get to trig, we'll draw all kinds of pictures of triangles. Making a list. Okay, some kind of problems you can solve with that strategy. Like if I said, take the letters A, B, C, and tell me all the different ways you could arrange them. ABC, BCA. Maybe a list would be a decent approach because there's not that many. Lists can get very big though. Okay. A lot of times we're going to set up an equation and solve it. And sometimes we use multiple approaches. Sometimes we make a picture and then we use the picture to make an equation. Or we'll use a graphing calculator to help solve an equation. So we'll kind of combine approaches. Okay, page 13 in your book gives all kinds of suggestions. They have a whole list of about 15 things for different strategies to try to solve problems. Okay, and then once you finally decide on what approach you're going to take, then we go through and we carry out that approach. So we'll try a word problem and work through some of these steps. All right, so the example we're going to look at involves a car rental company. And this company charges $15 to rent the car, and then they charge 20 cents per mile. Okay, so what I'm going to try to do is come up with a formula that if I plug in how many miles I drive, it tells me how much it would cost. Okay. How many variables am I going to need for this problem? Two. Okay, there's two things that I don't know. Okay, what's one thing that I don't know?
And how many miles do you drive?
Yep, how many miles you're going to drive the car. And then how many miles you drive will determine the dollar amount, the cost. Okay. Since I plan on graphing this one, using letters X and Y would make the most sense, because that's what we use when we graph. Now there's a reason I let Y be cost and I let X be miles. Another name for your X and Y variable are called independent and dependent. Okay? So what you have to do is figure out which variable controls the other. In this case, the cost is dependent on how many miles you drive, not the other way around. The miles you drive is not dependent on the cost. It's kind of a weird way to look at it. So the cost depends on how many miles you drive. So cost depends. So your dependent variable is always Y. And the variable that's controlling something, that's your independent. All right, so let's see if we can come up with an equation that would give me a formula for the cost. Okay, so what letter is going to be by itself on the left-hand side?
Y.
Yeah, I have y by itself. And Will, did you have, or I'm sorry, John, did you have a formula for the cost on the other side?
Yeah, I was going to say y equals 0.2x plus 15.
Perfect. That's it. Y equals 0.2x plus 15. Does anybody recognize that kind of equation? Yeah, what is that?
mx plus b.
Yeah.
Right. That was linear.
Yeah, perfect. This is the equation of a line with a slope and a y-intercept. It's y equals mx plus b. Okay? All right, so now let's use that equation to find the cost if we drive the car 50 miles. So Pat, if I'm going to drive 50 miles, where would I plug in 50?
Where the x's?
Yeah, x is the number of miles. So fill in 50 for x. So you get 0.2 times 50. So you got to pay that 20 cents for every mile you drive, but you only pay the $15 one time. That's like a one-time fee to rent the car. Okay, 0.2 as a fraction is 1/5. So in my head, I'm thinking, okay, what's 1/5 of 50? That's 10. Plus 15 is 25. You just use your calculator. But that's the cost to drive 50 miles. Now, can I just take that cost and double it to get 100? Why not? It's double the miles. Why wouldn't it be double the cost? Yeah?
Because you have plus 15 and 10.
Yeah. We don't want to double the plus 15. That's a one-time fee you pay. We're going to double the mileage part, but you're not doubling the 15. All right? So the cost to drive 100 miles. Okay, that's going to be 100 miles. Okay, that's going to come out to 20 plus 15, or $35. Any questions on that? All right. So that equation we just came up with, that's basically an algebraic representation of the problem we had. We've kind of taken out the fact that this problem was about a car, miles, and all that stuff, and we said, here's an equation. Y equals 0.2x plus 15. That represents our problem. Now, if you were to just show this equation to someone on paper, they could plug in anything they want for x if they didn't know what it represented. You could plug in 0, -7. Okay, you could plug in anything. But from our problem, really, there's only certain values of x that make sense. It's the number of miles you drive. So what kind of values would you probably not use for x, since we really know what it is? Yeah.
Negative number.
Yeah, you wouldn't use negatives. Okay? But somebody looking at this equation wouldn't know that. You could plug a negative in, do the math out, and get an answer. It just wouldn't make real world sense in our problem. Okay, so it's important to remember things like that. All right, so example 2, using the same equation. It says Sarah was charged $50 to rent the car. How many miles did she drive? Okay, what letter are they giving me this time?
Y.
They're giving me y. Okay, they're giving me a dollar amount. That was my cost. Okay? So this time I'm going to fill that in for y, and I'm solving for miles. Okay? This is what they're giving me. That's what I need to find. Okay, I'm solving for x. So I've got 50 equals 0.2x plus 15. Okay, so let's solve that real quick. Subtract 15 from each side. 50 minus 15 is 35. And Tyler, what's my last step to get x by itself? Yeah, just divide both sides by 0.2. Okay, so 35 divided by 0.2 gives me 175 miles. Good. Okay, so that's an algebraic approach. Fill in for the variable, and then solve for x. Any questions on that? All right, let's try it on the graphing calculator. We're going to go back to that equation we had. Okay, so on your graphing calculator, first thing you want to do, turn it on. Okay, if you're at the home screen, you can clear it, but we're going to get off this screen in a second anyway. Okay, and I want you to press the button in the upper left that says y equals. Okay, if there's anything already typed in there, just get rid of it. Okay, now on y1, what I want you to do is type in this equation. Y equals 0.2x plus 15. All right, so 0.2. The x button is right below mode. Okay. If you decide to pick a different variable in your problem, when you graph it on the calculator, you have to use x. Always have to use x. Plus 15. Yeah. Okay, so that's the equation of the line that represents our cost. And what I'm also going to type in is the 50. I'm going to put that on a new line. I'm going to put that on y2. Okay, so when I graph what's on the left, that's going to be a line. When I graph what's on the right, that's going to be a line. And I'm looking for where these lines are equal. What did that really mean in the picture? It's going to be where the two lines do what? Where they intersect or where they cross. All right? Now, let's start by doing zoom 6. Okay, so everyone has the same window. And if you do that, and we look at it, there's nothing on the screen. Okay, so one of two things. Either we type something in wrong, or what else could be the problem?
Way too far out.
Yeah, the window. Okay, when you put a line up at 50, that's a horizontal line at 50. Well, on our window, we're only going up to 10. This line is way off the screen. So we need to do what we practiced in last night's homework. We have to adjust the window. Yeah.
I don't know if I did something wrong, but I got like 5 dots on my screen.
Okay, if you have some dots on your screen, press y equals.
Yeah.
And I bet one of these plots is highlighted.
Oh, maybe.
Is it? So if it's highlighted and it looks like that,
Yeah, it does.
yeah, just go up to it.
Yeah.
Just press up, hit enter, and that'll shut it off.
Okay, cool. Yeah.
All right, so let's set our y max a little higher. Okay, we know we have to go at least to 50. Okay, that's our cost. So I don't like to put it at 50 because then it'd be on the edge of the screen. Yeah, so we could do 60, 70, anywhere like that's fine. Okay, now common sense, we already talked about our mileage. Mileage isn't going to be negative. So why bother looking at negative mileage? And technically, we already know the answer to this problem. How many miles does she have to drive? We already know it's 175. So again, don't type 175 in for max. Go a little beyond it. Now, if you didn't know it was 175, here's where you might be doing a little guessing. You'd put in a number, hit graph, see if it looks okay. If it doesn't, try again. That's fine. That's a good window. We can see where they're crossing. The calculator can automatically tell us where they cross. Okay, if you press trace, you can kind of go over and get an idea. Okay, it looks like it's pretty close to 174, somewhere around there. But we can do even better than trying to get an idea. The calculator actually has a feature built in that will find an intersect for us. Yeah.
I have nothing.
All right, so you type, you got both of those in Y1 and Y2,
Yeah.
and that's your window.
Oh, no.
Everyone else have a picture on their screen?
Yeah.
Okay, you got it? Okay. Did anybody know, or has anybody used the feature that finds an intersect on here? Okay, let me show you where it is. You press second, and then calc, right above trace. And if you want to find where two lines cross, which one do you think you pick? Yeah, the fifth option down is intersect. So pick that one. And now it asks you which two curves do you want to intersect, find the intersection for. You can have multiple lines on the screen here. So maybe you got to pick which two. In our case, we only have two. So you pick a point on the first curve, the blue line. You can pick a point anywhere you want on the second curve. Hit enter, the red line. And now the guess. The guess isn't really important here. Where the guess would be important is, let's say you had a line and a parabola. There's two intersection points. Wherever you put the guess, that's the intersection it'll give you, whichever one you're closer to. Okay, in our case, there's only one. Just get close to it, hit enter, and it tells us the answer. Okay, sometimes the calculator, when you find an intersect like this, it'll say something like 174.99999999999. Okay, if it does something like that, or if it says 175.000000001, round it to 175. All right. So after driving 175 miles, the cost is $50. Questions? Yep. Yep. So, okay, so on your calculator, all right, so make sure for your window, you're going to have these values in there. So we went -10. Really, we're not going to have negative costs. They're not paying us to rent the car. Okay, but you got to set your Y max at 70. Okay, any questions on how to calculate an intersect? Yes?
How do you get to the intersection?
Intersect, you press second, and then trace. Okay, and it's the fifth option down. Okay, and then, you're welcome. And then you pick a point on the first curve, pick a point on the second curve, do your guess, and it'll tell you the intersection. Okay, so for the graphical approach, there's really not a lot to write here. It's just the process I explained to you. Yep.
Yeah, when I put that in, something pops up. It says like only one function and up to 3 possible for that.
All right, you might have to reset. Okay, if there's anything kind of weird, especially on the newer calculators, they might give you a weird message. What I always do, go to second, memory, and you can reset the entire calculator. You could do it to mine if you want, but I already did it before the school year. So you go to second, memory, reset, and then reset. I usually do the first option. Okay. I'm not going to do it to mine, but if you do that, it should kind of reset it back to normal. You will lose any programs you have in it, but it'll at least give you like a fresh starting point if you're having a lot of weird errors. Okay, so you can always do that reset.
What kind of programs would be on them?
You can have, I mean, basically anything you can program a computer to do, you can program this to do. Yeah, you can write programs to do anything. Distance formula, quadratic formula, all kinds of stuff. Okay, so for the test tomorrow, Okay, what I'd like everybody to do, especially because of the program things, I mean, you can put anything in there. Okay, you could basically take 10 pages of notes and put it in there as a program. All right. What I'm going to do is, for the test, I'll have everybody use the one that they were assigned in class. All right. That way, it's fair because somebody that doesn't have a calculator, they can't put stuff on it, where somebody that has their own calculator, they could go home, put all kinds of stuff on it that somebody else can't. All right, so just to keep it fair for everybody, I'll have you use one of my yellow ones just on test day. You can use your own during the week, but on a test day, I want to make sure everyone's kind of has the same playing field. Okay? Any question on that? But yeah, there's all kinds of, you can put pictures on the color ones, you can do anything. All right, so in the title of the section, I talked about complete graphs. Okay, when you set up a viewing rectangle that shows all the important features of the graph, whether it's where things cross or whatever it happens to be, that's called a complete graph. Okay, a complete graph doesn't cut anything off. That's important. Let me show you an example of a graph. All right, let's do x minus 5, x plus 8, and x minus 2. Okay, you can just watch this. Okay, I'm going to do zoom 6. That is not a complete graph. Okay. I know that if I were to distribute all this out, okay, using FOIL, and do it all out, I would get an x cubed term somewhere. Well, the highest exponent in a polynomial tells me basically how many times it can cross the x-axis. So notice I said this would have an x cubed term. Crosses the axis 3 times. Okay. The other thing the exponent tells me is how many twists and turns the graph can take. Right? How many twists and turns a graph can take is 1 less than its highest exponent. All right, so if you distribute all this out, you'd have x cubed. Okay, 3 would be your highest exponent, which means this graph can turn up to 2 times. Well, it's probably turning somewhere, but I can't see it. All right, so what I would do is I just play with it. Okay, keep zooming out until I can finally see it. Okay, and this part is just a little bit of trial and error. Okay, that's better. I can see this turn, but there's one more turn that's still off the screen. So I'll just try 300, see what that looks like. Good. That's a complete graph. I can see all the important features. I know that it's not going to turn again, just based on the highest exponent if I distribute it out. And I can see 2 turns. That's all that's ever going to happen. This side's just going to keep going down. That side's just going to keep going up. Okay, so any questions on what I'm looking for a complete graph? Just write down the window. Okay? That's all you have to do. Okay, so here's another one to find a complete graph. Okay, what's the highest exponent in that expression? 2. So how many times can this graph turn? Once. Okay, this is your classic parabola. It can go down and come back up, or it can go up and come back down. Yeah. Okay. It's going to be one of those 2 shapes. Okay, let's type it in. X squared plus 10. And let me use the window that I had for the last problem. Okay, you don't have that window, but let's just see what happens. Okay, that's an okay window. I mean, it shows the turn. It kind of makes it look a little wider than it really is, kind of distorting the picture. But a good place to start is always zoom 6. Now, how come I don't see it when I do zoom 6? Yeah, this plus 10 shifts it up 10 units. Well, I'm only looking as high as 10, and I know it's a U shape. 10 is the lowest, and it's going to go up. So if I want to see it, try setting your y max, I don't know, maybe 25, and now you'll see something. And that's a more accurate picture of what it looks like, rather than making it look so kind of spread out. Right, so for that problem, all I would do is take my window and copy it down. I think this one was negative 10.
Good, put all that down, you just put like the.
Yeah, I just,
Max or like.
yeah, I just want that.
X and Y's.
Yeah. Those are the only things you really need. Let me just try to move this up. Okay, and that curve that we just drew, that's called a parabola. Okay, and that's generally the kind of thing we see when we talk about quadratic equations. Okay, that's the general form for a quadratic, ax squared plus bx plus c. The one that I just drew with you guys was a little simpler. Didn't have that. This was basically a 1. Didn't have that. So it was just x squared plus a number. Okay, if I add some of those other numbers in, I can change the shape of it and how it looks and where it is on the coordinate plane. Okay, let's try this one. Okay, let's graph the square root of x plus 20. Okay, but before I type it in, I want to just think about square roots for a second. What kind of numbers do you have to have under the root? You can only take the square root of what kind of numbers?
Positive numbers.
Positive numbers, and I'm being picky here. One more. 0. Okay, so we want to avoid negatives under this square root. Okay, so for example, if you plugged in negative 50, that would be a problem. We can't do that. What kind of numbers would I be allowed to pick for x here? Any number from negative 20 and what?
20?
And up. Yeah, you can pick anything from negative 20 and up. Okay? Just don't go lower than negative 20. If you do, and you plug it in, you're going to get a negative number under the root. Okay? And that's imaginary. Okay? We're not doing that. So let's graph it and let's see if the calculator kind of confirms what we just said. So go to y equals, clear anything you have, press second square root, x plus 20. Since I have an idea of where I need to look, I'm going to set my window before I even graph. All right, let's, we know we can't go below negative 20. But let's set the edge of our screen at negative 25 and see what happens. Okay, x max 10, that's fine. Now when we take a square root, unless you put the negative sign in front, we're not going to get the negative answer here. Okay, this symbol, when you graph it, means just the positive answer for the square root. And let's think about what happens. Okay, let's plug in a number like 10. Okay, so if we plug in 10, 10 plus 20 is 30. We're taking the square root of 30. That's not that big. It's only about 5, 5.5, okay, somewhere around there. So I don't think we need to go as high as 25 on the y max. I think we could probably even just go up to 6, 7, 8, somewhere around there. Let's hit graph and see what it looks like. Okay, there's our square root function. Notice this point way over here. Oops, this is at negative 20. And if you try to go beyond negative 20, it says y doesn't exist. Okay, we can't do it. Right at negative 20 is where it starts. Okay, and if you wanted to get kind of a more broad picture of it, you could zoom out. So what I do to zoom out is try to put my cursor somewhere in the middle of the screen. Press zoom. And the third option down is 3, zoom out. Okay, you can put your cursor wherever you want. Putting it in the middle is usually a good idea. And if you hit enter, it'll zoom the screen out so you can see a little bit more. And that's what your square root function looks like. It's kind of a curve that just goes in one direction. Okay, so the window we had before, that's perfect. The window we have now, that's fine too. Honestly, I would round these off. If I was writing this down, just write -12 and 19. Yeah. All right, well, let me take a look at it after. Okay, so any question on finding a complete graph for a square root function? Yeah.
Did you see that again?
I went to zoom, I went to 3, and then I put my cursor kind of right in the middle, and I just hit enter. If I do it again, the graph might start to look a little small. Yeah, that's not as good of a window, because now I can't even really see the curve here. So I might want to zoom back in. That's
So when there's a variable in like the x, you're just kind of, you guess to begin with to see where your axis would be, like how high that.
Yeah, sometimes you just got to guess a little bit.
Yeah.
And then if it doesn't work, adjust your guess,
Okay.
kind of play with it. Square roots are something you got to be careful with. We've got to avoid negatives under the square roots. And anytime you divide and there's a variable in the bottom. Okay, like if you were to graph something like this, something weird's going to happen at -2 because you can't fill in -2 for x. You divide by 0. Okay, so any questions on 1, 2? All right, so we'll start part of 1.3 with the half hour we have left. Whatever we get to, we'll get to, and we'll stop there. Okay, so in that first example we did about renting a car, I told you that the x and y have names. I already gave you some of them. I said x was called the independent variable, and y is the dependent. Well, you can also call it input and output. Okay, you plug in for x, you get something out for y. The other name, and we're going to use this one quite a bit, is called domain and range. Okay, you guys really just did this on the last problem. Okay, on that square root problem, you all were able to tell me what values are you allowed to plug in for x. Somebody said from -20 and up. Well, that's what we call the domain of this function. It's the values that you are allowed to plug in for x. Some functions, the domain is anything you want. Okay? You can plug in any number and there's no problem. Some functions, we got to be careful. Okay? Like when we divide by a variable or when we take a square root with a variable. Those are the two times you got to be careful. Okay, so what is a function? Okay, not every single thing we draw on the screen is necessarily a function. Okay, but the simple way to say if something is a function is every input has exactly one output. So every time you plug in a value for x, you get exactly one answer for y. Sometimes in Algebra 1, you see this done as a picture. So they do something like domain, range, put some values here, put some values here, and you draw arrows between them. Here's an example of a function. Basically, if I plug in something, I know exactly what I'm going to get, and I get only one thing. If I plug 1 in for x, this diagram is telling me I'd get -4 for y. If I plug in 2 for x, I would get 6 for y. That's an example of a function. How about if I did this? Okay. The question you want to ask yourself is if every value in the domain points to exactly one value in the range. Is that true here? Right? So if I plug in 1, is there any question about what I'm going to get?
No.
No. If I plug in 2, is there any question about what I get? No. How about if I plug in 3?
No.
No. No matter what value you give me in the domain, I know exactly what I'm going to get in the range. Every value in the domain points to one value in the range. You can use a value more than once, but what you can't have is something like this. That's a problem. Now if I said to you, if you plug in 2, what are you going to get? You'd say, I don't know. You get 2 different things. If you have 2 different things, you could get, that's not a function. Every input has to go to exactly one output. Okay, that's what makes something a function. Domain, we already said this earlier. That's your set of inputs. Okay, it's what you are allowed to plug in for x. And the range, that's the set of outputs. That's what kind of answers are you going to get when you plug in for x. What kind of numbers do you get for y? Do you get negatives? Do you get positives? Do you get only numbers between 10 and 20? What kind of answers do you get when you plug stuff in for x? That's your range. That's your output. Okay, unless otherwise stated, we have to pick from the real numbers. Okay? In other words, we are not using imaginary or complex numbers yet. Okay, so our domain, the things you plug in for x, you have to pick from real numbers. So don't say you're going to plug in I. That's imaginary. Okay, when we write a function, there's 2 different ways you can write it. Okay. Most people have probably seen this before, y equals. Does anybody know the other way you can write a function besides y equals? It has like a letter with some parentheses. Yeah? Yeah, you can use f of x. It's the same thing. It's just a different way to write it. Okay, I just want to make sure you're aware of both notations. Okay, if you already know that notation, you don't need to write it down. Just make sure you're aware of it. We've actually kind of already did example 1 with the very last problem, but let's take a look at that. All right, so here, what I want to do is find the domain and range. Okay, what kind of numbers do we need to avoid under square roots? Can't have them. Negatives, can't have negatives. So what does that mean you would be allowed to pick for x? Any number, it'll be any number from this number, and then,
3 and 4.
yeah, Brendan?
3 and up.
3 and up. Perfect. Okay, so that's your domain. You can pick any number greater than or equal to 3. Or another way you might see it written in our book, you can pick any number from 3. The bracket means you can include 3 to infinity. You can never reach infinity, and something we can't reach, you put a parenthesis on. These are exactly the same thing, just showing you how you might see it in the book. On the test, I don't care how you write it. But we'll kind of use both of those all year. All right, so this gives us an idea of where we're going to set our window. Let's give it a shot. So if you've got the last one in there, you just change it a little bit. Okay, I got to pick values that are 3 and up. All right, so I'm going to set my window. I'll start it at 0, just so I can see the start. let's go, I mean, we can go as high as we want. I mean, let's go to 15. Okay, on the y-axis, here's where we got to kind of take a guess. Well, if I plug in the highest value I have right now for x, 15. 15 minus 3 is 12. The square root of 12 is between 3 and 4. So I'm not going that high on the y-axis. Let's say maybe set it to 10. And when you take a square root, this symbol means the positive answer. Don't worry about negatives. All right, so tick graph, take a look at it. Perfect. Okay, it starts at 3, and it's going to keep going to the right forever. And now the range is basically how high the graph is going to go. Okay, up and down. How high do you think this graph is going to go? It's just going to keep going. Okay, and if you want, you can go second graph, and it'll give you a table where you can plug in different values for x and see how high y goes. Okay, try 25. Okay, try 500. Try a really big number. Okay, y is just going bigger and bigger and bigger. Okay, it's never going to stop going up. Kind of goes up slow, but it keeps going up.
How do you type into that?
On your calculator, what you might have to do is press second, table setup, and then put the independent on ask. That'll allow you to type in for x. If you put it on auto, you can't. Now, bless you, what's the lowest y value we could ever have?
0.
Yeah, doesn't go any lower than 0. Try your lowest x value. Y is 0. Okay. As you go a little higher, y gets a little higher. It's never going to go lower than 0.
So it's greater than.
Yep. Range is greater than or equal to 0. Or you can write it down. Okay, same kind of question here. Find domain and range. Now, this doesn't have a square root. We're not dividing by a variable. We're just taking something and squaring it. What kind of numbers are you allowed to square?
All real numbers.
Yeah. You can square positives, you can square negatives, fractions, decimals, 0. Domain is all real numbers. So you can write it just like Tyler said, all reals. Or you can write negative infinity, which we can never reach, to positive infinity, which we can never reach. Now the range. Sometimes it's helpful to look at the picture. Okay, x squared. I know that's kind of that U shape again. Okay, I just typed it in. I'm going to do a zoom 6. That's going to be perfect. Okay. What's it look like the lowest value is on the y-axis here?
4.
Yeah, -4. And if you want to calculate it, there's actually a feature you can do, second calc minimum. And then you have to pick a point somewhere to the left, kind of puts in that dotted line. Pick a point somewhere to the right, and now you're telling the calculator, look between these dotted lines to find the lowest value. Okay, so this is saying when x is 0.0000000008284. I told you the calculator might do something funny like that. So basically, when x is 0, y is -4. And the range goes from -4, how high? Infinity. Just keeps going up. So greater than or equal to -4. Or you can write it as -4, which we can include. We can reach that, and we do reach it, all the way up to infinity. Any questions on that one? It just takes a little practice to get used to domain and range. One thing, I'm not going to go through this one, but when I see absolute values, I know absolute value always makes a number positive. So my range is not going to include negative numbers if you have an absolute value in it somewhere. All right. So just practice plugging in a number for x and telling me what you get for y. Okay, and then we'll finish up. Okay, so all that this means is I want you to take -2, plug it in for x, tell me what you get for y. Okay, so you just plug it in, and then just evaluate it. So what do you get if you plug in -2 for x? 5. Okay, -2 squared plus 1 gives me 5. Okay, what do you get if you plug in 3 for x? 10. 3 to the second power plus 1 is 10. What do you get if you plug in a for x?
A squared plus
Yeah, you can't do anything with it. It's just a squared plus 1. And then the last one they have us plug in is x minus 3. Well, that's x minus 3 squared plus 1. How do you do out x minus 3 squared? Yeah.
You would have to separate it into one.
Sure, you can separate it out. And then some people might have learned distribute or FOIL, okay, different ways to do it. But you'll get x squared minus 3x minus 3x. And then -3 times -3 is positive 9.
Plus 1.
Plus 1 is a plus 10. Okay, so that's just basic, plug something in and evaluate it if you can. If it's a letter, that's all you can do. And this will be the last thing. We'll stop here. Not all equations are functions. Okay, just watch me sketch this. You can write that down. Not all equations are functions, but just watch this. Second, square root of x. And I'm going to graph this at the same time, if I can figure it out. Why isn't that a function?
They're never going to meet.
It's 2 different lines.
Okay, pretend, yeah, I know it's 2 different lines, but pretend it's all the same color. Let's say I let x be 3. How many choices do I have for y?
You would have 2 different choices.
Yeah, that's the problem. I've got 2 choices. If x is 3, could be up here. I could be down there. I don't know which one. So the very simple way to tell if something is a function is this test. Okay, vertical line test. How many people have seen that before? All right, all that the vertical line test says, if you have a picture and you can draw a vertical line anywhere in the picture and it hits the graph more than once, whatever you just drew is not a function. Okay, so this picture that I had, if I sketch a vertical line, hits it twice. This is not a function. How about a circle? Would a circle be a function? Nope. So if I got a circle, I can put a vertical line in and it hits it more than once. So those are not functions. How about that? Yeah. No matter where I put a vertical line, it's only going to hit it one time. Never hit it twice. How about that? Yeah. Horizontal line would hit it more than once, but not a vertical line. Okay, so those are functions. Right? So that's a simple way to tell if something's a function. Draw a vertical line, hits it more than once, not a function. All right, so tomorrow we'll have our test. Okay, it's going to be on sections 1.1 through 1.1.3, just what we've covered up to. Okay, we'll do the summer reading, and we'll go over the homework before the test, and I'll answer any questions to review. Okay, a lot of the homework on page 20 is just graphing calculator. So if there's nothing to write down, don't worry about writing anything down. Page 30, it's a little bit on domain and range and plugging in.
Calculator just to make sure we can do it.
Yeah, just practice it on the calculator, but there's a lot of problems you're not going to have to write anything down. All right, so page 20, it's 6 to 10, 18, 21, 29, 32, and 38. And then part of 1.3, it's page 30, 3 through 8, 11, 13, 16 through 19, and 24.